One of the biggest disconnects we used to have in box product world, where we used to ship software as a standalone product and give it to customers, is once customer takes the product, it is in their environment. We don't have any idea about how it is being used and what kind of issues people are facing unless they come back to Microsoft support and say, hey, we are using this product and we get into these issues, can you please help us? But with advent of services, one of the beautiful things that happened is now we have the ability to collect telemetry about various issues that are happening in the service. So this helps us proactively fix issues and help customers mitigate outages, and also join the telemetry data from deployment side of the world all the way into coding phase, which is the first phase of software development lifecycle.
Welcome to the Microsoft Research India podcast, where we explore cutting-edge research that's impacting technology and society. I'm your host, Sridhar Vedantam. The process of software development is dramatically different today compared to even a few years ago. The shift to cloud computing has meant that companies need to develop and deploy software in ever-shrinking timeframes while maintaining high quality of code. At the same time, developers can now get access to large amounts of data and telemetry from users. Is it possible for companies to use machine learning and artificial intelligence techniques to shorten the software development lifecycle while ensuring production of robust cloud-scale software? We talk about this and more with Chandra, Maddila and Chetan Bansal, who are research software development engineers at Microsoft Research India. Chandra and Chetan, welcome to the podcast and thank you for making the time for this.
Thanks, Sridhar, for hosting this.
Thanks, Sridhar. Thanks for having us.
Great. Now, there's something that's interested me, when I decided to do this podcast with you guys. You're both research software development engineers, and Microsoft Research is known for being this hardcore computer science research lab. So, what does it mean to be a software developer in a research org like MSR? And how is it different than being a software developer in, say, a product organization, if there is a difference?
Yeah, that's a great question, Sridhar, about the difference between the RSD role, which is Research Software Development Engineer at MSR, versus the product groups in Microsoft. So, in my experience, the RSD role is sort of open-ended because oftentimes research teams work on open-ended research problems. So, the RSD engineers often work on things like prototypes and building products from the ground up, which are deployed internally and which are the precursor for products which are shipped to our customers. So there's a lot of flexibility and openness in terms of what the RSCs work on, and it can range from open-ended research to actually building products which ship to our customers. So there's a wide spectrum of things and roles which RSC plays.
Chandra, what is your take on that?
I think Chetan summarized it pretty well. So RSD in general is much more flexible compared to a typical software engineer role in product groups. You can switch from areas to areas and products to products. So I, for example, was working on NLP for some time, then web applications and learning platforms for some time. Then I switched to software engineering. So we have this flexibility to move across different areas. And also one thing I think, do as RSDs is working on long-term problems from ground up, which takes some time to incubate and productize. Whereas software engineers in product groups have well-defined scope and well-defined problems which are aligned to their product's vision. So that way they have slightly more constrained in terms of what kind of problems they work on. But at the same time, one of the greatest advantages people in product groups have is the accessibility to customers. So they are very close to customers and they really work on customer problems and ship things quite faster.
Right.
Whereas RSDs in MSR don't have access to direct customers.
Interesting. So it sounds like it's kind of a play between customer access and freedom as far as RSDs are concerned.
Yeah, as RSDs in Microsoft Research, we have a lot more flexibility and provision to explore more interesting areas in research. new and upcoming areas like probably quantum computing or blockchain or advances in AI, ML, etc., and do more exploratory things.
Just wanted to add another thing here. So, a lot of times people have misconception that in Microsoft research or even other research organizations, a doctorate or a PhD is required to get a job or to work for these organizations. But there are roles such as RSTs and product managers, program managers, or even designers, which people can take on without need to have a PhD or a doctorate, and they can still contribute to the research happening in companies like Microsoft.
Great. Now, we keep hearing nowadays that the process of software development has changed tremendously over the last few years. So, what's actually caused these changes?
I think to start with, there are two things in my opinion, have caused this sort of revolution in the software development or software industry. So one of them is this move to the services-oriented world. So we are no longer shipping box products in a CD or a DVD, but we are actually shipping services. We are actually selling services which are used by our customers, unlike before where you ship a software and then that's used by our customers for a couple of years and then they update it. So I think that's one key change which has happened in the last decade. And the other major paradigm shift which has happened is the move to cloud. So even in terms of software deployment, today it's being done on cloud instead of on-prem, which is within the premise of a customer or a company. So that has brought on a whole range of changes in terms of how software is developed and deployed and maintained within small and big companies like even Microsoft. And today, startups or any new company doesn't have to actually spend a lot of money in capex, capital expenditure on buying servers or hiring people to maintain those servers, but they can basically ship and operate out of cloud, which saves a lot of money and time. So in my opinion, these are the two major paradigm shifts which has happened and which has positively impacted the software industry.
Compared to 90s when we used to, for instance, ship box products, now everything is becoming a service. That is also primarily driven by customer expectation. So these days, customers are expecting companies to actually ship services more faster, make the new features available at much faster pace, which is also accelerated by the development and growth in cloud computing technologies, which makes software companies or software developers to scale the services really fast and serve more people and ship things much faster.
So, I know for a fact that earlier there used to be these long ship cycles where, somebody would develop some software, there'd be a bunch of people testing it, and then after which it would reach the customer, whether it be the retail customer or an enterprise customer, right? I think a lot of these processes have either disappeared or been extremely compressed. So, what kind of challenges and opportunities do these changes provide you guys as software developers?
So this rapid development models where people are expected to ship really fast brought down the overall ship cycles, the duration of the ship cycles down to even like days. Or in a single day, you experience the entire software development lifecycle, all the steps of the development lifecycle, starting from coding to testing to deployment, in a single day. This definitely poses a lot of challenges because you have to make sure you are shipping fast, but at the same time, you are making sure your service is stable and customers are not experiencing any interruptions. So you need to build tools and services that aid developers to achieve this. So the tools and services has to be pretty robust and make sure they catch all the catastrophic bugs early on and aid developers to achieve this feat of shipping their services much faster. So the duration between someone writing a code and that code hitting the customer has come down like significantly, which is what we all need to make sure we support.
I just want to add two more things, two more changes which have helped evolve the software development life cycle and processes. First is the possibility of collecting telemetry and data from our users. So basically, we are able to observe how our features or our code is behaving or being used in near real time, which allows us to see if there's any regression or if there are any changes or if there are any bugs which needs to be fixed. This wasn't possible in the past in the box software world because we didn't have access to the telemetry. The second aspect is having a set of users which are helping you test your features and services at the same time. So now we can sort of do software development in parallel as we roll out our current set of features.
Cool. So it sounds like you guys are now able to get a large amount of data as well as telemetry from the users, right? How does this actually help in making the software development lifecycle more efficient or faster?
So I think there are two aspects. Like one of them, which I just highlighted, was now we are getting real time or near real time telemetry in terms of how different aspects of our software or services are being used. And the second is if there's any regressions or any anomalies which are happening, we are able to detect that and then resolve that very quickly, which wasn't possible before. So I think these are the two aspects.
One of the biggest disconnects we used to have in box product world, where we used to ship software as a standalone product and give it to customers, is once customer takes the product, it is in their environment. We don't have any idea about how it is being used and what kind of issues people are facing unless they come back to Microsoft support and say, hey, we are using this product and we get into these issues. Can you please help us? But with advent of services, one of the beautiful things that happened is now we have the ability to collect telemetry about various issues that are happening in the service. So this helps us proactively fix issues and help customers mitigate outages, and also join the telemetry data from deployment side of the world all the way into coding phase, which is the first phase of software development lifecycle, and give valuable insight to developers so that when they code itself, they have an understanding of how this code is going to behave out there in the wild and be more cautious and cause less bugs or issues.
There have been a couple of terms which have become, I think, very predominant, very prominent over the last few years. There are two terms that come to mind immediately to me. One is Devops and the other is AI Ops. What exactly are these?
So DevOps is basically a commonly used term across the software development industry, which refers to basically the set of practices and tools for developing software, deploying software, and shipping software. So basically how different parts of our industry, different companies are actually building software, and what are the set of practices. For example, how do you do code reviews? How do you check in code? How do you deploy the code? So different set of practices and also the tools and infrastructure which is involved. So in my opinion, that's sort of the definition of DevOps. It's a very abstract term which refers to different set of practices and tools for software development. Lastly, AI Ops. So that's basically a recently introduced term in probably in the last few years. Because of this access to telemetry and data from our software and users, we are able to leverage data science and machine learning for optimizing a lot of key aspects of the DevOps lifecycle. For instance, while doing code reviews, can we use machine learning and data science for catching bugs? That's a very simple example, but that gives you an idea that how AI ops or artificial intelligence can be used to help with different aspects of DevOps, and that's branded as AI ops.
So DevOps actually is a combination of two words, right? Development plus operations. In box product world, when companies were shipping software through CDs or DVDs, as Chetan mentioned, we used to develop software and sell it to customers. And all the operational aspects of the software, that is deploying the software in their organizations and maintaining it and making sure the software is running properly, etc., is in the hands of the customer who take the software from the vendors like Microsoft. But with the advent of services, Microsoft is also becoming a services provider. Like Satya famously says, Microsoft is now a services company and we provide solutions to customers. So we definitely got into this innate need of doing operations also inside Microsoft itself, which makes us do both the development and operations together, Devops, inside Microsoft itself. So this basically combines different aspects of software development lifecycle, starting from coding, testing, and also deployment and customer support, and filling the feedback loop back into development and iterating over all these phases again and again. AIOps is a term that has been coined in last couple of years. AIOps specifically means using technologies like artificial intelligence and machine learning and leveraging that to solve problems and operational challenges in software development. For instance, you take a fancy AI algorithm and use it to solve root causing problem in software services, right? That is a classic example of using AI for solving a real problem in operations. And we have a variety of different problems that occurs in the operation side of the software development now because of the scale at which software development is happening. And using and applying AI ML techniques to solve those problems put together can be called as AI ops.
Okay, now I know you guys have been working for a few years on this very interesting research project called Sankey. And I think this has elements of using AI and machine learning in making the SDLC more effective. Talk a bit about that.
Sankey is a project which we started at the end of 2016. One of the primary goals of Sankey is to provide an ability to join various data that is being collected at different phases of software development lifecycle and leverage techniques like AI ML, do analysis on top of the data, and provide valuable insights which can aid various stakeholders in each phase of this software development lifecycle.
The whole motivation of behind Sankey was to infuse AI ops into the software development processes across Microsoft. And it has been a huge collaborative effort with several collaborators such as B. Ashok, Rahul Kumar, Ranjita Bhagwan, Sonu Mehta, Jim Clevine, and not just these folks, but also several research fellows across MSR and our other counterparts from across Microsoft.
Okay, now I get the feeling that both of you have kind of oversimplified what Sankey is actually. Uh, I've sat through various talks in which there seems to be a huge amount of work that goes in different components that feed into Sankey, which seems to be kind of like a platform. Why don't you guys talk a little more about that? What Sankey actually is and what the different constituent parts are, so to speak.
So Sankey is actually a platform that we have been building. Sankey basically have loaders that ingests data from various phases of software development lifecycle. For instance, from development phase, it ingests data about pull requests, commits, various builds. From testing phase, it ingests data about test cases, test executions, what is the status of the tests. And from deployment phase, it ingests data about alerts, exceptions, and various other telemetry that is collected at the deployment phase. And we basically put all this data together in a single queryable data source. That is very important because this data exists in various disparate data sources which are exposed at various levels. And Sankey basically gets all this data into a single relational data store, which can be easily queried and joined against each other. Then we use this data, we feed it into various AI and ML tools to provide insights and recommendations in various phases of software development lifecycle. For example, we mine all the commit data, that is which files are changed together, which files go into a pull request together, etc., to basically discover rules that explains the files that are always changed together. And we use that knowledge to provide recommendations when developers are creating pull requests if they are missing any files to include in their pull requests. We call it as related files analysis. Similarly, we developed tools like Orca, online root cause analysis tool, which is intended towards root causing service incidents and service disruptions as quickly as possible. So in case of Orca, it's pretty interesting that it uses data from both left side of the software development lifecycle and right side of the software development lifecycle. That is data from commits and code that is written and the differences of code, and the telemetry that is collected at the deployment side, that is exceptions, errors that are occurring in the service. So Orca basically takes all these exceptions, errors that are happening, and has an ability to point them towards the actual code change that introduced these problems in first place, which is pretty fascinating because this greatly reduces the amount of time developers spend in root causing issues, which typically takes probably a couple of days or sometimes even weeks, depending on the complexity of the issue. And Sankey has close to 8 such recommenders, which combines data from various different phases of the SDLC and leverages the AI/ML techniques, the AI ops processes, and make the entire development lifecycle more optimal and efficient.
So to add to what Chandra just said about Sankey, I just want to mention that in the beginning of the podcast, we briefly discussed how the move to cloud and service-oriented software development has posed some new and interesting challenges for software development. But in this case, we are actually able to use that to our advantage, since in Sankey, we are basically building services which we can deploy and iterate on very fast based on the feedback from our users and also based on the telemetry we are getting from the services. And lastly, because of this cloud-oriented architecture, we are able to leverage big data technologies and these service-oriented architectures, which allow us to leverage terabytes of data or telemetry which are being produced by different user-facing services, and then combining that with machine learning algorithms and providing insights which are very valuable to the end users of the Sankey platform.
Now, is Sankey available to the world outside of Microsoft?
As part of Sankey, one of the key focus has been on making sure that all of our techniques and algorithms are published in major software and system conferences. So we have published research papers and articles about the Sankey platform architecture and even the 8 different recommenders which Chandra talked about.
Okay, so if it's all available in the public domain, I think we'll make them available along with the transcript of this podcast. Okay, so let's do a little bit of crystal ball gazing now. Where do you guys see software development, engineering, and DevOps evolving in the future?
I think that's a great question. As Mark Andreessen famously said, software is eating the world. So a lot of traditional companies are becoming more and more tech companies. You can see that in every industry, automobile, pharmaceutical, retail, everywhere, tech is penetrating a lot. This actually makes software development more complex, and we need to react to customer requests in a more faster ways, which basically makes AI ops much more relevant. Using all the AI and ML technologies to make the entire software development lifecycle more efficient and deliver value to the customers and users who are subscribing to our services is going to become way more important.
To add to what Chandra just said, so I think there are 2 things which makes me excited about how we can evolve Sankey and other similar projects to prepare for the next shift in software development industry. So I think first is the more and more usage of software and machine learning and cyber physical systems, for example, in self-driving cars, in agriculture, and these are systems which are like safety critical, time critical, and impact humans in a big way. So evolving Sankey and others and similar tools and techniques, and for those vertical of software and services, I think will be a key challenge and opportunity. And the last one is the move from software industry has seen this software 1.0, 2.0, and now this move to the edge, right? Where a lot of times the cloud or the compute is available on the edge of the network so that it's accessible, it's located close to the user. So how we can leverage Sankey and other similar techniques for the edge focused cloud is another interesting aspect which we are excited about.
Okay, so Chandra and Chetan, this has been a fantastic conversation and fascinating. Thank you so much once again for your time.
Thanks, Sridhar.
Thanks, Sridhar, for this insightful conversation. Thank you.